So we'll go ahead and get started. We have 3 presentations today. The first is going to be from Vašek Petraš, and he is a PhD student at NCSU pursuing a, I don't know what your doctoral degree is going to be in, but...
me neither, actually. Geospatial analytics, that's what we say.
Okay. And so he's working with the Center for Geospatial Analytics and is big on GIS and open source. So welcome, Vašek.
Thank you. So thanks for coming. So we will continue with what you have seen in the fashion show from the point of view of GIS. So we have 30 years of NCGS conference, and last summer we had 33 years of GIS. So GIS started somewhere around 1983. That's at least what the official birthday is. And we'll try to do this introduction because William Shatner can speak much better than I. Let's see.
It's no news that we all use maps to do our jobs. There are often problems using them in the traditional paper form, particularly when we can't seem to get the right information in the right format when we need it. There should be a better way. GRASS is a Geographic Information System, or GIS. It's a better way to manage, store, and use your mapped information. GRASS is simply a computerized system which stores, analyzes, and displays different types of mapped information. GRASS supports installation managers in carrying out their mission with higher reliability in a cost-effective manner.
Okay, so let's see what you have seen from Captain Kirk. And so this is how GrassGIS looks now. It's a little bit different, but so now it has 30 years of development behind whatever we have now. It can do vector analysis, 2D, 3D rasters, image processing, all these different areas. And it's a single software package, so you don't install any plugins or extensions just to get the basic functionality. It's all there. It has different user interfaces, and it's used in several different software packages, like R and QGIS for the geospatial processing. Most lately, it is also used in OpenDroneMap, so that's definitely something to keep eye on. And it's for free, so you just have to pay when you need support, when you need new development. That's when you pay. The license costs exactly $0, and you don't need to deal with any license servers, obviously. And the development is user-driven. So the users actually decide what to do, and they interact with the developers. What's the next step? It's part of the OSGeo Foundation. That's a project or a foundation which is taking care of different open source geospatial projects. So what I will look at in the presentation will be different things which were added to GRASS, which were maybe innovations at the time. Maybe they are still cutting edge even today, and how they are actually used or served today, or how they were developed or improved. So this is like a typical example. Solar radiation processing module. It is available since 1993, but it was renewed many, many times. And the latest improvement, which is coming in the next version of GrassGIS, somewhere this year probably, it's a parallelized version of it, which is very nice for the current data, of course, because with the LiDAR data we have much more detailed terrain models or digital surface models, so we have much more to compute Either if you want to do something like cast shadow analysis, what you see here, but also maybe sun hours during the year for growing crops or some plants on your property. There is a relatively unique, or maybe very unique, watershed delineation algorithm, which is based on least cost path. This was added sometime around 1989 when it was used to compute a global watershed map. And it doesn't need any depression filling, so it runs on the original digital surface model. But it was updated in 2011 for really massive data sets. With vectors, we always have this problem that the topology is not correct. So GIS always requires or tries to have everything nicely polished and topologically correct. And one way how to achieve it is manually, but then the other way is to do it through automated tools. So here is an example from one of the cleaning tools, which was introduced way in the past, but it is continuously improved because, of course, there is always this new other topology bug or topology problem you didn't know before. GrassGIS had a 3D view from early 90s, and it was renewed several times. It's used most of the time for analytical visualizations, and here you can see UAV flight path and reviewing the UAV flight path visually in the 3D. Maybe you heard about GRASS in relation to interpolations. Well, the reason for that is that there is many different interpolation algorithms, and also these algorithms can work in 2D, 3D, or 4D with different variables. And this is also worked on even now. So in the next version, there is a parallelized version coming in. And there is also a really fast version, in this case actually available as an add-on, so not actually included in the main GrassGIS. So then one of the really important features is that GrassGIS runs as a 64-bit application. It is since 2005 on Linux, Mac, and other Unix systems. And why it is important is that you can actually, in the one application, one process, can use more than just 4 gigabytes of RAM. So even if you, on your computer, even if you have 16 gigabytes of RAM, but your program is just 32-bit application, even your computer is 64-bit, it depends on the application, so the application can't actually use more than this 64-bit of your memory, so it can't actually make use of all of it. So it means that it either can't process the data at all, or it will process them in much slower fashion. So with 64-bit, you can use all this memory you need, because with current hardware, that basically means unlimited. So this is long established in Grass community. There is not that big fuss about it. And you can compare it with some other software if you have there the 64-bit support. But there was no, this support was not on Windows, which was added just recently. Also with this 64-bit, 32-bit support, Grass supports different operating systems. Probably all you know and several you don't know. And it will run on any HPC clusters, and it will also run on this Raspberry Pi device, which this is the whole computer. So Grass will also run on this if you need for some application like in the field. So all these innovations, they actually come with stability. So what do I mean by that is So here is an example of, it is a raster algebra expression written as a command line code, which can be executed in Grass. And that's from a book from 2002, from version 5 of Grass. And it actually ran as it is in the current Grass.js release. You can make it better with new best practices for the syntax, but it actually runs. So if you learn it, you have to spend some time learning raster algebra, obviously. You will actually get the returns in your investments because there is the thing is just preserved. Similarly, it works with the whole modules. So module or a tool, when it is obsolete for some reason, there is a new replacement. The tool is actually still available, although there is a replacement for it. The big or the latest big release was Grass.js 7.0. Now we have the current one is 7.2. And there are several things newly included. This one is actually also just an add-on. It's a length form detection algorithm. It's very scalable, and it was developed by Spatial Informatics Laboratory, University of Cincinnati. So this is an example of a module which was developed by a group of researchers. And here is another example of an image segmentation algorithm. So here we are in remote sensing, where the original code was developed during Google Summer of Code. That's a Google stipend project for developing open source code. And it was later improved during Grass.js Community Sprint. That's an event when different developers come together to actually one place to work together for some time. But since then, it was worked on by different people, and this can be like any number. In 2016, I looked, and it was 4 different people other than the original 2 developers were working on it. So you can see that maybe somebody develops it at the beginning, but even if they are not actually taking care of the code for some reason, there are some other people who just carry on and update the code. A big addition to Grass.js was Spatio-temporal Framework, which allows you to work with a time series of data, not only visualize them, but also analyze them, like find where is spring coming or some other things. Here, this is a just visual comparison of precipitation and temperature, and this would be animated over time. In vector analysis field, we had a big addition in 2003 of different basic vector analysis tools like Traveling Salesman, and then it was again improved and improved in different years. So now there is a big suite of modules which can do all the things for a vector analysis, including cost for turns and nodes. But all of this is not just about the code itself. There is more to it. So one thing is that all the modules where there is some research behind, there are actually in manual page references to scientific papers. So if you are not sure what this algorithm is, you can always go to the original scientific literature and look how it was developed, what are the use cases. And you can also see who is the specific author of that code. So this is again a screenshot from a manual page of a module. So we can see that the author is Marcus Metz, and we can also get a link there to source code, when you can actually, if you need to see what is the specific equation or code used, you can go there. You can also go to the history of the code and see all the authors which did all the contributions and this is line by line, so you can have a very precise idea what's happening there if you actually need that. Also, all these algorithms are discussed, how they are used, how they can be used, and that's happening in public on a mailing list, and that's all archived, so you can go through it, you can see if the algorithm was questioned, what were the issues, and this goes all the way back to 1991. And so I was saying that there is all the tools which you need, all the basic tools are included, but if there is something actually which is special, some user contributed it, the code maybe not, it's maybe not matured enough to be included in GraphGIS, there is a Grass add-ons repository where this user contributed code resides, but it's not only code, you can actually install it from the graphical user interface in Grass, and you get the application on your computer with graphical user interface without actually the author taking care of creating the graphical user interface for you. And this even works if you are interested in that. If you are developing in C or C++, you get even distribution of binaries of your code on Microsoft Windows platform. On Linux, it just happens automatically, so there's no need to do anything. So here is an example what happens when a user is not sure about what the algorithm is doing. So this user look at the result, and then he went actually to the source code, and then he found there the equation, and the equation is not exactly what he expected. So he opened a bug report, and now it is reviewed who is actually right, if the original author of the code or the user. Then there is one other completely different issue, and that's usually we can see that people are, and that would apply to myself as well, we are limited by the tools, the software tools we are using. Right, when we have a hammer, everything looks like a nail. So how Grass tries to fight against this is that it covers all the different fields. So you can do remote sensing, and at the same time you can do network analysis, and it just depends which algorithm you need. You don't have to install any additional extension. I already mentioned that. And if you want to use Grass, so how can you use it? So of course there is a command line interface. It was always there. It's still there. But if you don't want that, there is the graphical user interface, which is actually pretty powerful. It has Graphical Modeler, but it also has a Python interface. So that's already from 90s when Python was created. Since then, GraphGIS has a Python interface. There were some improvements over the years. And most recently, it has also integrated Python editor. So now you really just, you have to just push 2 buttons to get your first Python code running. So I would encourage you to try that. If you are using R, there is a package rGrass, which is not officially part of GraphGIS, but it is well supported and it is well matured. There is also RQGIS, where you can get all the QGIS functionality and all the Grass functionality together. There are interfaces for many other languages, so you just pick what you need. In QGIS specifically, if you are using QGIS, GraphGIS is available in the processing plugin, all the different algorithms. And there is also a specific GraphGIS plugin, so that's something different. And that includes even more GraphGIS algorithms and gives you access to some specific GraphGIS features. We have also a history of GraphGIS being deployed on a cloud, even before I guess it was called cloud. So in 1994, there was GrassLinks, which was WW interface to GIS. You can use GraphGIS in a environment where you use client-server setup. And most recently, we have GrassGS deployed on European Space Agency Proba V mission exploration platform, also on Roll app and Grass. I'm not sure how to actually pronounce it. So these two latest ones are commercial services. You can check them out as well. And what I would recommend is actually using command line. It doesn't have to look like this. It can look like this, where you have also a tangible user interface. So I suppose you all have seen our booth with a tangible landscape, which is a tangible user interface. And what's going on in Grass now? So there is a new thing which is a little bit harder to digest, I think, even for me as a more experienced Grass user, I would guess. So if you are familiar with raster algebra, this is a tool which allows you to do similar operations. So you basically can write mathematical equations, but these equations go over time. So you can do something like, instead of a vector buffer, you can do a temporal buffer around your data. And it can be used to find out different things which are time dependent. So here is a use case where they use it for hydrothermal coefficient. And the nice thing is that if you have the equation of the hydrothermal coefficient, which depends on the temperature and precipitation and the different dates, it will actually translate to the temporal algebra right away. What we are working on at NC State, it is a urban growth model called Futures, and that's integrated into Grass as an add-on. So if you are into urban planning, that's something to see. There are also some details, like default color table was changed in GrassGS 7.2. So you are all familiar with the rainbow color table at the bottom. And I'm not sure if you can see it, but there are these vertical lines. So you are actually supposed to see the vertical lines, but in the rainbow color table, there are different areas where you don't see it in the green. While the new color table called viridis, it will allow you to see everything. So that's new default, so it's like encouraged so that users actually, if they don't pick a specific color table, they at least use one which has good perceptual properties. There is this new hydrology model. So there is a lot of different hydrology model in GrassGS. This is specifically advantageous for flooding of the cities, or if you want to avoid that, I guess. Here is a nice example of an algorithm which was requested by a user. So the user was saying, well, I would like this SLIC Superpixels segmentation algorithm for my remote processing workflow. And this other user was saying, well, I would like this too. We recently moved from some proprietary software, and we would like to use this algorithm for our processing. And 5 months later, this issue was closed because somebody actually implemented this algorithm. Because it was probably advantageous for them, and they just needed somebody to push them a little bit. So in the presentation, I included different resources you can use. These are, most of the resources are what we created at NC State. There are some other ones as well. And that's all from me. If you order Grass in next 10 minutes, it's for free. And this actually applies even after that 10 minutes. There is a link to the slides, so if you want these resources and so on, grab that. And we are also doing GrassGS meetups in Raleigh, so there is a link for that as well. And I think I will take questions either when we will be changing here, so just individually, or after all the other sessions. Thank you.